Hi girls, we're going to take a look at Theorem 9, which is 5a3. And we're also going to take a look this time as a theorem and a converse. And a converse is exactly the opposite to what the theorem states, but it's also proved in proving the theorem. Okay, so this theorem is taking a look at a parallelogram, and there's things that you already know about a parallelogram. Sorry, I just turned this way, it's a bit easier again. So you know that in a parallelogram, this side and this side are equal, and this side and this side are equal. This angle and this angle are the same, and this angle and this angle are the same. They're things that you already know, but now again, you are trying to prove that in this section. Okay, so this parallelogram is labelled A, B, C, D. Could be labelled any other which way. That's the way they've chosen in this one. Okay, so the first thing I'm going to do is I'm going to draw a diagonal. So I'm going to take my parallelogram and I'm going to split it into two congruent or equal triangles. So again, this brings up the reminding yourself of what the word congruent means and taking a look at what that means as well. Okay. Within that then we're going to have four angles, 1, 2, 3 and 4. Okay, and our aim is to prove that this side is equal to this side is equal to this side. And we're going to consider now that we have two triangles. So we have the angle ABD and we have the angle BCD. So we have two triangles now, and we know that those two triangles are equal to each other. Okay, so we're looking at a proof. So consider the two triangles ABD and BCD, which is where we are here. We know that angle 1 and angle 3 are equal to each other because they're alternate angles. So again, like you've seen in the previous one over there, you're seeing a Z shape. So you're looking at 1 and, what do they start with? 1 and 3. So again, you're looking at your Z, 1 and 3. And again, you can draw in your Z to see your alternate angles. Okay, so you can see here. So that means 1 and 3 are the same, and it also means 2 and 4 are the same. Okay, you also know that DB is common to both sides of your triangle. So you have two triangles. You're saying that, you know, angle 1 and 3 are the same because they're alternate angles, and you're saying you know that both triangles have one side that's exactly the same, BD. Okay. You also know that 2 and 4 are the same, again, because they're alternate angles, so the Z the other direction. And therefore you're able to say that triangle ABD and BCD are the same. And it's by the rule angle, side, angle. So you've proved that two angles are the same and one side is definitely the same. Therefore, I can say that the two triangles are congruent or the same. Okay. Once you can do that, then you prove that A and AB is the same as CD. AD is the same as BC. Angle ABC is the same as angle ADC. And angle BAD is the same as BCD. And you've done that now because you've proved that those two triangles were congruent. And again, go back to what the word congruent means. You see it down here in the corollary, a diagonal. So if you cut a parallelogram in half, you create two congruent triangles. So they are two equal triangles. Okay. And you've proven that those two triangles are equal. Now, the converse then of the theorem, so it says in a parallelogram opposite sides are equal. The converse of that is if you have two opposite sides that are equal and two opposite angles that are equal, it must be a parallelogram. So it's like saying two, I don't know, let me see. What's it like? How could you put it in a different way? So we'd say, Hannah and Emma went out the door. The door was open, and when I looked around, Hannah and Emma were missing. Means the same thing, but they're called converses of each other. So they're you're saying it the opposite way around. And they mean the same thing, girls. I wouldn't obsess about it. Again, you've got a definition back on the previous page about what converse is. So the converse of a theorem is the reverse of a theorem formed by taking the conclusion as the starting point. So state this time the conclusion is that the opposite sides are equal, and then saying what you were trying to prove. That makes it a parallelogram. Okay, when you have opposites and sides and angles equal to each other, then it's a parallelogram. Okay, so that's that theorem. And again, I know these are hard to learn, girls, because it's not something you do very much of, but you're going to work on Theorem 9 now till Wednesday. So I'll put this up and I'll ask you to work on Theorem 9 till Wednesday, and then I'll do a video for you for Theorem 14, which is longer, but it's actually easier. So I think this one actually, while it looks longer, it's actually easier than some of the other ones. And then the two harder ones, and the corollaries, and this one seems to be the one that comes up most often. So you've seen this picture in the exam papers 100 times. You've seen it in your mock paper as well. So those ones are the ones that come up more often. So we'll take a look at those ones then next. All right, best of luck. Talk to you soon.